before you do the final tightening. That does two things. One, it looks nice, and two, it keeps the bracket from touching the hot terminal, which can cause a short. If you're not careful, that's what the bracket tends naturally to tighten up and touch the terminal, so we don't want that to happen. Now, we get out our beautifully powder painted oil breather can, and there's one special attachment here, rubber grommet that goes over it. It's a little snug, almost like the distributor drive, but it's not. You put it in like so, and we get out the special bolts that are used to attach the oil breather can to the generator stand. And we need 4 washers, 1, 2, 3, 4, and 2 6mm nuts, and sometimes 2 wrenches. Small wrenches, the smaller the better to get in there. We use the best washer on the outside, 1 washer under the head. That fits in that way. The other washer under the nut. Like that. Put a washer on the other bolt that goes on the inside. Here you can use the lesser of the 2 bolts as far as goodness is concerned. Goes with another washer and nut on the other side. Sometimes to get enough travel you have to tighten down this one side a bit. Force the gasket to compress so that the other side can be screwed on. Okay, now the fun begins. It's hard to hold, so you have to usually put a wrench on it. Then use a very short 10mm across the flat wrench box end to tighten it down. Try not to scratch the fan shroud or the cylinder shroud when you do this. Use your hand as a guide to keep it from doing that. And tighten it down until it's pretty snug. Then go to the rearmost one and tighten it. It's really a pain to get to this, but you only have to do it once in every 100,000 miles, hopefully. There we go, now we're tightening down nicely. 3, 2, 1, ignition. Okay, likewise, tighten this one down. Voila! Oil breather can is now attached, just like it should be. While we're here, we may as well put the fan belt on. And we have new generator halves. They come with a lovely little part number mark right here. And it's hard to remove, incredibly difficult to remove, so you're better off not removing it, and the fan belt will remove it for you. Put the front bracket is the one with the notches for taking everything off. Don't forget that. You put that on, and you get at least 10 of the washers. And you put 7. I found 7 to be the lucky number here. 7 come 11, but it's 7. On in the middle between the pulley halves with a new fan belt. That's the proper number of washers for 5, come on, 6, 7. And then I prefer Porsche fan belts to say Porsche on them. Of course, I'm afraid you won't be able to find these anymore, but the Maestro does have them for engines he does build. Even Stoddard no longer does supply the Porsche ones. They used to a while ago, but they have just Continental. Continental works fine. They're a good belt. They're 825 millimeters long by 9.5 millimeters wide, and that's the number you should remember. This one with Porsche, I always put the Porsche so you can read it. That's the way they want to go anyhow. Then you get out your CAD-plated rear pulley half. Boy, look at that baby shine. Isn't that neat? Stick that baby on there. Put on 3 more shims at least. You want to have at least a total of 10. If you're too few shims, the nut won't tighten things down well enough. And if it doesn't tighten things down well enough, it'll rip out the center section of the inner hub. Then good luck trying to get things off, especially when you're broken down out in the boonies. So now, we get our 36 millimeter wrench out. The one we used to torque down the flywheel nut was the last time we used it. And we can just torque around, like so. And things will tighten down automatically, and that's not too bad, about a ½ inch of play in the middle. We can put our wrench, our screwdriver, in place here against the nut. Now we don't over tighten this thing, which we really can do with a 36 millimeter socket. Just want to tighten it down to where we can get it off again. Check it, not bad, pretty good. We'll probably have to readjust it in 100 miles or so. But in general, the belt should slip a little bit on compression, but not terribly much. That's about right. 7 washers in between is a good number. Okay, boy, it's looking like a Porsche engine now, isn't it, huh? Next step, because the next thing we may do before we put the manifold adapter plates on, is to put on the top linkage crossbar and the spring plate. This takes a spring plate type, all newly CAD plated. To do that, we CAD plate also the other end here, the ball. So we put the ball on first. I like to use nice new washers on things and nuts because they look nice that way. And usually we can do most of the adjustment on the other side. But 1 washer on this side, 1 washer on the other side. Put it in like so. This is hard to hold, this particular one. You have to hold it with a pair of pliers. I know it sounds gross, but that's the way it is. Tighten it down. But you don't have to tighten it down, you have to really lean on it. It's not too bad. We take our cross linkage, top cross linkage bar here, or top linkage crossbar, depending on how you want to call it. Put some lovely wheel bearing grease, heavy duty, high temperature stuff, the best stuff you can get. Wipe off the excess. It's messy, black. You can use Bosch high temperature grease too, Bosch distributor grease. But I found actually the wheel bearing grease seems to work a little better. The bracket that operates the bar is on the left hand side as you're facing the engine. You stick that in, put that in below the plate, the bracket that holds the fuel line. You get out the spring plate that goes on this side, and 3 6 millimeter bolts. These are not critical bolts, so they don't have to be matched names, but of course I like to use them. 3 washers. Get the spring plate in, put the washers on. Be careful you don't drop anything down. Inside the intake manifold now, it's very close here. Screw in 3 bolts. Get them all in loosely, then you can use either the 10 millimeter wrench or 10 millimeter socket on the bolts. There we go, socket's right here, we use it. Now to adjust the spring plate tension, we can do it by adjusting the number of washers on either side of the ball, or we can put spacers underneath these bolts between the spring plate and the fan shroud. Let's see how this works. If we're really lucky, we won't have to do anything. But luck hardly ever comes to those who don't work for it. That's not too bad. It's pretty smooth. Wiggle it back and forth. It's got a little bit of friction there, but not much. That's not too bad. In fact, I think we'll go with that. Alright, now we're going to put the clutch and pressure plate on. This is the mark made by the machinist to balance the pressure plate and flywheel. And we have here the pressure plate, we have here the clutch disc, and we have here the tool necessary to adjust everything, which is nothing more than the Porsche main shaft that's been cut off. It's the ideal tool. You can buy a cheap wooden one for about $3, $4, $5 from a foreign auto parts store, but these you can use either from a Porsche transmission, which this is, with a bent main shaft was no good, or a VW transmission. Okay, so we put the clutch disc in. We've cleaned off the flywheel here with Comet and steel wool. Got it nice and clean. Find the corresponding mark on the pressure plate. Put that on like so. Then the dowel pins will all align very nicely. Put the part of the main shaft in place into the flywheel nut. I like to use the Allen head bolts and new washers. And we attach the Allen head bolts loosely. There's 6 of them. Put all 6 in, then tighten them down one turn at a time while we check to make sure that there's no binding anywhere in the main shaft piece, the clutch alignment tool as it were. If there is binding, we have to loosen the Allen head bolts and make sure that we align the clutch disc to be certain that when we put the engine in, the the main shaft of the transmission in our car will align properly with the splines of the clutch disc. If we don't do that, just randomly put the pressure plate and clutch disc together, we will find, much to our chagrin, that we can't get the engine to go into the car because we can't get the main shaft to align with the splines of the clutch disc. So here we go. You need a 6mm Allen wrench, and what you should do is just tighten things down till they're snug. You can get a 6mm Allen wrench attachment to your socket too, but it's hard to get everything in place here. Now you should do it across alternately, that is across 180 degrees of the flywheel pressure plate, but right now we'll just tighten things down. Now see, the alignment tool is tight, so we have to loosen things up a bit. We were too hasty until we can once again move the alignment tool. Tap things around, tighten down the bolts we have not yet tightened down. Make sure the adjustment tool will adjust and move in and out. This takes a bit of time, but a bit of time well spent, because the clutch is very important. To do any work on the clutch, you have to remove the engine and then put it back in again. And to remove the engine is not much fun. I like to put these things in once and not have to play around with them. So if you do everything beforehand right, you won't have to play around with them, hopefully. So once you get the nut snug, at that point you can torque things down in one turn at a time, alternately. Like that. Keep going around, one turn at a time. And about every turn or so of the bolt, stop and check the alignment tool. Make sure it moves back and forth easily. If it doesn't move back and forth, you have no choice but to stop, find the reason why, which usually means loosening all the bolts again and starting over. After a while, when everything is tight or is starting to snug down, then the clutch disc can't move anymore and you'll be all right. But still, make sure that you tighten things down, tighten the bolts down one turn at a time maximum. You can watch the fingers of the pressure plate And if one side gets too far in, they will slowly come inwards towards the flywheel, that tighten the opposite side or loosen the side that's in too far, and you'll be okay. After we get everything tight, we'll take a hammer and hit the end of the wrench here as like an impulse wrench would, impulse engines, and that will make sure everything is nice and tight. It won't come loose when you don't want it to. So far so good. Balancing is the most important thing you can do to your engine for long life. I balanced every engine, whether it be a Porsche, a Volkswagen, or a Chevrolet V8. When you balance things that can be balanced perfectly, you should. It makes them run a lot better and last a lot longer. And you can tell everybody the maestro said that. Now at some point here, the flywheel is going to start to turn like that, which is good because then you can bring everything up to where you are and then make sure it's tight. When you do that, it's kind of like bringing the bolts to you like that, and that's indicative of the fact that everything is now getting very tight. You should always, when you're done, have everything within a half a turn of being tight. You'll occasionally drop the wrench, it happens. Check the clutch shaft, or the main shaft piece, make sure with your adjustment tool, clutch alignment tool. Okay, we now have all 6 pretty tight. You can use a 3-pound sledge, but you don't have to. Just use a regular hammer, whack it a few times, drop the wrench again. This always happens. These things are really a pain. Bring everything around so you can get to it. Give it a few more taps. You can use Loctite on these bolts too, it doesn't hurt anything. I'm a believer in Loctite for certain applications. I think it does a good job at preventing bolts and nuts from loosening up. And now, it's 4, we got 2 more to go. We're just about done. While we got this side of the engine, this is actually the front side of the engine, towards you, we should put on the thermostat, and we have everything here ready for that. It's all done. Don't forget to remove the clutch pilot tool. Here's a thermostat. It requires a special short 8 millimeter bolt, 14 millimeter across the flat, kind of like the cam plug. Put the thermostat in. It's got a little cord, 2 cords cut out of it, and you put the alignment, the adjustment bolt, one that ties it down, 14 millimeters across the flat, and tighten it down. Now we're pretty much done here for the time being. We still have the fuel line and linkage to put on. We'll do that a bit later. So I'll turn the engine around, and now we found the piece we need to do the distributor. And the piece we need is this piece here. It's usually found in the lower end gasket set, though some of the gasket sets nowadays don't have it. It's nothing more than O-ring seal. And you pry it over the distributor shaft, put it right there. Helps to lubricate it with a secret sauce, because a new one is sometimes hard to put in. Lubricate the area where the distributor goes with the secret sauce. Doesn't hurt. It also helps now to crank the engine around to top dead center on number 1 cylinder, which we can tell from the cord, which if we install the distributor drive correctly should be parallel to the split of where the main case attaches to where the third piece attached to the main case halves. then the OT mark should be aligned with the notch in the case. And lo and behold, it is. Now, there's a notch on the body of the 050, like there is on most all Bosch distributors. There it is. That notch, the rotor should point to at top dead center on number 1 cylinder. Now, the 050 is kind of unique in that when it does that, the rotor is not pointing at about 4 o'clock, but more like 7 o'clock. So let's put it in, rotate it around. As I was saying, it sometimes helps to have a little bit of persuasion in the form of a rubber hammer, like that. Rotate around till it snaps in place, and when you put the rotor on, you'll find it's pointing at about 7 o'clock. Now that's top dead center. There's a notch. You get things vertically aligned. At that point, if you pull the rotor, the point's just barely beginning to open. And lo and behold, they are. Get the snaps out of the way. We will adjust the timing a little later with a volt ohm meter. Show you how that's done. Time being, we'll put the rotor back in place. Get it aligned so that this notch in the rotor is directly above the notch in the body of the distributor. And we will then tighten down the bolt that holds the distributor in place. For the time being. That's a pretty good rudimentary timing. It should be very close by the time we get done with this. We then attach the wire to the coil on the right hand side of the coil. You can put it either way. I personally like to have it that way. Looks nicer. And we put the distributor cap on. I like to take this ID part number tab off of this thing. WD-40 works well to take off the sludge. There's a notch in the body and a particular notch here in the cap, and they align, snap in, put the snaps in. This is number 1 cylinder. Don't forget that. We then get out a wire set, which in this case can be a VW wire set. Open it up. Find the coil wire, which magically appeared in front of us. It's the first thing to put in. It gives you the feeling of accomplishment. You're doing something right. You can't screw up the coil wire. It's the shortest one, and it goes from the coil to the center of the distributor. Take the other wires, unscrew the Volkswagen ends that are here. You might want to save the skirt. That can be saved. The rest of it can be tossed. It can be unscrewed by hand. Throw them away, but save the skirt. You might want to save the ends too, but if you have more than one wire set, you don't need to save the ends. Unscrew them all. Then, get all 4 of them, 4 ends together, and you'll find you got 2 the same length and 2 there about the same length. That makes life easy. You take 1 long and 1 short. You take the O-ring seals, which are actually tied together doohickeys, and you put them over the 2 wires. Helps to lubricate them a little bit. Now, here comes the trick. The long wire is going to go to number 1 cylinder. So you should arrange it like so the long wire is on the bottom. You then get out the Stoddard. They're the only guys that make these things. They're little rubber tunnels, as it were, like this. These are the tie downs. The little nipple on the end, which I'll show you in a second, goes into the sheet metal here. Okay, put a little secret sauce on it. That allows easily the wires to go through. In fact, it's so nice and slippery, it allows your hand to fling it across the room. Get the other one out. Have your assistant go find that one. Push the wire. A little more secret sauce required here. Push the wire through. There we go. Bring it down. Put the other wire through it. Get another one of the tied together doohickeys, just an O-ring, but the right diameter to work. Other O-rings are not the right diameter. And if they're not the right diameter, the wire won't look nice. Get out the original Porsche ends. I like using Porsche ends. Stoddard has them. Other people may too. But Stoddard's the main source. They have a spike in the center, a screwed spike. And they screw into the wire, just like the VWs did. Screw them down till they're tight. Get the other one out. Screw it down. Step over to the right-hand side of the engine. Stick the number 1 plug wire on the spark plug that we've nicely installed. Stick the number 2 plug wire on. Now remember, the number 1 is the lower one here. So keep that in between your thumb and forefinger as you run it through. That's number 1. And on 050, number 1 is over here, if you remember. Firing order is 1, 4, 3, 2. Cylinder is 1, 4, 3, 2. Here's number 2. So we take number 2 plug wire, put it in there. Put the cap on. We got those 2 wires attached. Repeat the process. Now on this side, the number 3 cylinder should be underneath. So we arrange that underneath. Take the tie together doohickey, put it over the one wire, over the other one. Take the nice lubricated with special sauce tie down doohickey, put it in. This time it goes in, not across the room. Get the other wire through. Push, struggle, push. Nothing is worthwhile unless it's obtained after a struggle. Take the other tie together doohickey, the O-ring, put it over both wires. Get out the remaining 2 original Porsche wire ends. I like using them. They're a lot easier. They have a little knob on the end. They're a lot easier to pull off. When you want to get the wire off, you pull on the knob, not the wire. The VWs are extremely difficult to get off. They're tapered, they have no knob. And if they get wet with oil or anything, good luck getting them off. Okay, firing order 1, 4, 3 is there. 3 is going to be here. Put 3 on. Trace the wire, it's the lower one. 1, 4, 3, it goes there. 3 goes in like that. Put the cap on. The only one remaining is 4. It goes in there and here. Now, put the cap on. Arrange the wires. You can move them back and forth through the tie together doohickey. You can move them back and forth through the tie down doohickey. Get them to where they're happily arranged, about like that. Put some secret sauce on the nipple. I bet you like doing that. Put some secret sauce on the hole. Get out your special wire installer. Arrange things. Get it right there. And here's where we separate the men from the boys. Give it a whack. Doesn't go in. Give it a few more whacks. It goes in. That's what she said. Come over to the other side. Special sauce on the hole. Special sauce on the nipple. Arrange things. This is a little tight here. The wires, the VW wires are not exactly the right length. But they do function, though number 2 is somewhat on the tight side. Oh, so hold everything. Don't hit your finger when you do this, but you have to come somewhat close. Get things arranged. Bring the other tie together like you can see it here. Voila. We install the 050 distributor, original plug wires, tie together doohickeys, tie down doohickeys. Okay, now our next step is we're going to be using Weber carburetors. We have a Weber carburetor adapto plate. This is the better kind of adapto plate, and I'll show you why. When you open it, you'll find the adapto plate part of the kit is bored here. They recently added that improvement, and when you stick that on the Solex carburetor, the smooth bore actually does line up pretty well with the Solex intake manifolds. Now the one problem these kits have is that the particular gasket they use here is not the right size. The hole's too big. This hole here in the center is too big. I don't like using these gaskets, so I don't use these gaskets. These ones that go between the top of the adapter plate and the carburetor are fine. They work okay. No problem with these. But the other ones suck. So what we do is we go to our top end gasket set and we get out 4 of the Solex gaskets that are normally used to get on either side, actually 8 of these things, normally used on either side of the insulator block on Solex carburetors. And we put them between the Solex manifold and the adapto plate. We don't use the ugly, useless Weber carburetor gaskets that come in the kit. We use these instead. Now you can put mucilage on them, but I don't like to do so. I find there's very low chance of leaks anyhow. We get out the nuts and bolts from the kit, the Weber kit, and they are, we find, the same type of Allen head bolts that we used on the pressure plate. 6mm Allens, conveniently enough. You already have the wrench. They go in the countersunk holes in the adapto plate, like this. Now some of these adapto plates may have been machined off a little bit, so the trick is to put all 4 of these bolts in place like you see it here. Screw them each bolt down a little bit because we want to screw them down in turn. If the jig they use is a little bit off, we find this is the only way to install this adapto plate with short of machining down the bolt heads all the way around so they will fit in. In fact, this particular adapto plate's not too bad. Looks like it's going to make it. You got to make sure after you tighten these things down, though, that the bolt heads do go below the base of the adapto plate. If they stick above the base of the adapto plate, remove the bolts and grind them the heads down so they stick below the base of the adapto plate. Otherwise, you'll be sorry, because they will, if they stick above the adapto plate, the Weber carburetor will not fit flat. If it doesn't fit flat, you will end up having a problem. And the problem is an air leak. So make sure they all 4 of the Allen head bolts will in fact fit below the top of the adapto plate. Okay, it looks like we win this time because it looks like all 4, if we can get this one down, are going to fit below. Yes, it is. How about that? Thank you, Porsche guys. Okay, tighten them down. We don't want to overdo this. We are screwing steel bolts into aluminum intake manifolds against an aluminum adapto plate. So it's best not to redo them, or not overdo them. Okay, we'll take a slight break now. Okay, we've got the all 4 of the Allen head bolts that hold the intake manifold adapto plate, the intake manifold tight, and they're all below the surface of the adapto plate. Take the 4 studs that come in the adapto plate kit and screw them into the intake manifold adapto plate. Don't screw them all the way down. Screw them in about halfway to 2/3 of the way. If you screw them all the way in, you won't have enough stud left to put the nut on. That's a minor defect in these adapto kits. I've written them letters about that, but they never seem to listen to me. They think they know best, and they don't. So screw them down to where they're about 2/3 in the adapto plate. And then you can use the gaskets they provide, which do work okay, except the holes are too big. These holes are bigger than they should be to fit over these 8mm studs. Ridiculous to have 2 big holes. I may make up my own gaskets and make kits up that have the right size holes. The reason is that these are a problem is if they go the wrong way, they'd actually uncover or actually go over to the area where the other 6mm Allen head screw is, and if they do that, they can cause an air leak because that goes to the outside world. So you got to make sure you twist them to where they don't cover. So when you put the Weber carburetor on, you don't get a leak. So make sure when you put these on that they're up against the stud in such a way as there's no chance for a leak between the stud area and the indentation of the Allen head bolt. Now the way to avoid that is take some red RTV, General Electric type, and stick enough in the Allen head bolt so that when you put the gasket on, it will squeeze a little bit out, but not much, and you can paint that area there with aluminum paint so everything looks kosher. And that will also prevent leaks. I just don't understand why they couldn't make the right size hole here. It's no big deal, but they don't do it, and it annoys me very much. I'm going to make up my own gaskets for these things. I'm sorry, I don't like these. We go to the other side, and the 4 Allen head bolts and our Solex intake manifold gaskets. We do not use the gaskets that come in the adapto plate kit because they're inferior. They also have another problem too. Besides having the inside hole too big, they've got 2 holes here. You don't need 2 holes here. It's ridiculous to have 2 holes here. You only need 1. One for the 1 Allen head bolt that goes through everything. These things are ridiculous. Throw them away. Don't use them for anything. Put the Solex intake manifold gaskets, arrange them over the stud holes so they're very nice. Put the adaptive plate on carefully. Like I say, you can use mucilage if you want to, but I don't. That way you can get them off easily. And screw the Allen heads in, all 4, before you tighten any one down. And that way you can be assured that everything will go in pretty effectively. Get out your Allen head wrench. Tighten them down 1 turn here, 1 turn there, 1 turn everywhere, and do it all evenly. If you don't do it evenly, the adapto plates are sometimes off enough, like I was saying, that you can twist the adapto plate and not allow the other bolts to get in. These adapto plates in 1986 seem to be a little better done. Maybe illegals coming in are a little better educated now, I don't know. Okay, but get them all fairly nice and tight, evenly. Ah, there's one that's kind of tight. You can put the secret sauce on the edge of the bolts to lubricate things. That does tend to help. Or if you have to, you can grind the side of the Allen head bolt down so that it will clear with no problem. But these seem to be pretty much in good shape, better than the average adapto plate. I like to provide the best Weber kits with the best adapto plates and the best Weber carburetors, and let me tell you about Weber carburetors. This year has been terrible. They've been out of Weber carburetors for the entire summer, when the biggest demand is, of course, naturally, by Murphy's Law. And the Webers that finally did come in to this country, the United States of America, were the wrong Webers. They were used on Fiats or something. They have 2 inlet lines. They have all kinds of strangeness, including a working enrichment circuit for a choke. They have 31 millimeter Venturis rather than 28, which is actually beneficial. And what I'm going to do is use those Webers on this engine. We're going to make them work right for this engine. 31 millimeter Venturis is very close to the Solex original equipment 32 millimeter Venturis rather than 28 millimeter Venturis of the regular 40 IDF Weber. What we have on Weber carburetors is the 40 IDF. If you want to tighten these things down, you can take a 13 millimeter wrench, put it on the Allen, and it gives you much more leverage. Tighten things down. The 40 millimeter Weber has a 28 millimeter Venturi usually, and the 44 millimeter Weber has a 36. And that is either too small. 28 is smaller than the Solex 32. It's the same size as the Zenith, but being a Weber they flow better. And the 44 Weber has a 36 millimeter Venturi, which is somewhat too big. I wish Weber would make a 32 millimeter Venturi carburetor, and I think I'd be very happy then if they had a 40 millimeter bore. It'd fit on the adapter plate, they'd fit on the Solex intake manifolds, they wouldn't have interference with the sheet metal, the Solexes don't have. The Weber manifolds, intake manifolds, don't use unless you have 44s. The reason for it is not only is there interference with the vertical sheet metal and getting the spark plugs out would become a real pain, in fact almost impossible unless you pull the engine, which you don't want to do to change the plugs. So I don't like using the 44, I don't like using the Weber manifolds that come with some people's Weber kits, simply because they're used only with the 44s. And you use the 44s only for high performance applications. Street engines are best served by the 40 Weber. These new 40s though have 31 millimeter Venturis. And because they have 31 millimeter Venturis, they're 3 millimeters bigger than the 28s of the 40 Webers. I'm going to try them out and see how they do. In fact, we'll try them out on this engine. But they have a problem. They have a T inlet line that has inlets on both sides, which means you got to pull one inlet out and plug it. And the inlet line is pressed in, so you have to unpress it out and then tap it for a plug. Lots of fun. While we're here, pop up the oil filler can. Take the oil filler can gasket, which was munged up here a bit from 100,000 miles of use. Make sure you clean it off with WD-40 so no dirt and crud gets inside. Use a fairly clean rag if you have one left. And then the good side, which is up against the can top, put so it seals. And then you can get another 100,000 miles of use out of this thing, like so. And now we're approaching the finale here. All we have to do is put on the Weber carburetors, check the timing, get the fuel line and linkage set up, and we'll be all set. Put, of course, the dipstick in, and put the drain plate and oil drain plug in place. And we'll do that in a few minutes. The screen and sump plate are of two different kinds. This is the type with this engine. It's got a small hole to accommodate the small pickup tube of the earlier engines before '63. The screen is a very fine woven screen with an appropriate hole for that type of early smaller pickup tube. Okay. The post-1963 engines have a bigger pickup tube and therefore need a bigger hole in the magnet, like this. They take a screen likewise with a bigger hole, appropriately. This screen is a much less fine screen. It's a coarser screen. Really, to me, it's not much of a screen at all, because those holes are about 1/8 of an inch by more than 1/16, something like 3 or 4 millimeters by 1 or 2. And they really don't screen out much of anything. This screen is a much finer mesh screen and will actually do something, help keep particles out of your engine. Because once the particles get past that screen, I'm sorry, but they're into your engine. The filter we have is a bypass filter, not a full flow. And if it gets into the pickup tube, it's going to get to the bearings. Anyhow, we'll be using this screen here, plate. And the way it works is you go to your lower end gasket set and get out 2 of the sump plate gaskets. There are 3 in the lower end kit because Super 90s take 3, but we don't have a Super 90 here. You put one gasket on. Helps to have all studs in the sump plate. If you have some bolts, you can actually take the bolt out and drain the oil, which is good. It makes life a lot easier. But if the bolt falls out, then all the oil will drain out too, and you'll have a problem. Push the gasket over the studs. Sometimes they're a bit tight in this situation. Screen, though looks dirty, is actually clean, just old. We didn't plate the screen. Stick it over, push it down. Make sure the pickup tube protrudes nicely. Put the other gasket on. Sometimes you have to play like it's a third piece seal and get it all over the studs evenly. And of course put the nice CAD plated sump on. That goes on fairly easily. Get out 10 6mm washers. Of course, stick them on. That's pretty straightforward. Keep the smooth beveled edge to the outside and the sharp edge to the inside, and that makes them look a lot nicer. I like to use the new nuts on the screen and sump plate. They look very nice when you're changing the oil. They come off nice. The threads are in good shape. That sort of thing. If you have any studs that are messed up, you can remove them by either the double nut technique, if there's enough stud to get off, get both nuts on to get it off, or by just a pair of vice grips, usually. In some situations, you have to weld a nut on and get them off that way or use a stud remover. But they usually come out. They're not held in nearly as tight as the case studs are. So once we get these on, we'll tighten them evenly. And I won't really bore you by showing you how you tighten up each one, but it really does help to go alternately back and forth and work your way from the middle to the outside. Middle of the stud area here to the either end. Keep the manufacturer's logo on the outside if you can. It makes for a much nicer arrangement. And there we have them all on. Okay, we won't, like I said, we won't bore you tightening them down right now. Put in the drain plate, or the oil drain plug, which is this. We've CAD plated it. Everything on the engine. Non-critical fastener, we will CAD plate. Don't overdo this. This is a pipe thread. So just get it tight, but don't lean on it, or you can have a heck of a time getting it back off again. About like that. So let me tighten these down, and we'll go back and put the carburetors on and the rest of the odds and ends and fire this engine up. Okay, we got the plate pretty much tied down now, and this is how you tighten it down in this pretty much this sequence here. When you do fire up a new engine, like I was saying, you got to change the oil at between 30 and 50 miles. Then again at 300 and 1200 miles. You really want to do a nice job of breaking it in. You do that by dropping this plate. I know it's a pain because of the 10 nuts. It takes some time, but it doesn't take that long. But you got to drop the plate each time and clean the screen and the magnet, because there'll be some magnetic hair on the magnet, that is iron particles from the rings, etc. There may actually be some crud from both crud that got into the engine and crud that's formed in the engine. You want to get it out. The first oil change is most important. That should occur anywhere from like 10 miles to 50 miles, no more than 50 miles. Second one should be around 300 miles, and the third about 1200 miles. We'll tip this back now and put the carburetors on. Like I was saying, we're using Weber's, and we have them right here. This is a new type of Weber. It required some modification to work. It had two fuel inlet lines here. One just like that on this end, and that's patently ridiculous. You only need one. In fact, it's hard to deal with the second one. So we took it out, tapped the area here, and put a plug in it. These velocity stacks are actually from Delordo. I happen to like them, and they serve well on Webers. There are some plugs here. These are vacuum lines that this particular Weber has. This is a different model Weber. It's got a non-adjustable accelerator pump except with two pins, usually for not enough and too much, or too much and way too much. But there's been a great Weber shortage in the summer of '86. Net effect being these are the only ones I can get my hands on for this engine. The big advantage of them is they have 31 millimeter Venturis, which to me is almost ideal. I'd like to have 32 millimeter Venturis like the Solex 40 PIIs have, but this will do just fine, I think. I want to try them out and see how they are. Linkage arms are ones I get. I don't like the ones supplied by Weber anymore, or the Weber importer. They're pretty lousy. I like these better. The balls are pretty nice. You have to do a little trimming sometimes here at the stop, but it works all right. What else can I say? These Webers come with a working fuel enrichment circuit. Most all Webers just have a block-off plate like this, and I removed the fuel enrichment circuit mechanism and just put a block-off plate, excuse me, since Porsches don't have any chokes and don't really need them. We don't need them either. So all in all, they look like fairly decent carburetors now. You got 3 vacuum lines, a couple vacuum line takeoffs below the throttle plate and some above it. For operating either vacuum advance or retard distributors, we plugged them all. The idle mixture screw is recessed rather than easily accessed, so you have to get a small, thin screwdriver to fit in there. But overall, it's not a big deal. We'll put these on, see how they do. And in fact, we'll put them on now. So what I have discovered on these gaskets, as I pointed out, is the hole is too big to fit over the stud. It wiggles around too much. you can get either some RTV or some Loctite Formaseal and just put a dab on the top of the 6mm bolt Allen head, just to fill up the Allen head. We will clean this off, clean off the excess. Just want to have enough to where the gasket will force out the remainder and we don't have too much excess forced out. It's not the most convenient tube I've ever seen. You take and just leave enough left so that the gasket, when tightened down, will force it out. And not inside the carburetor, but in fact inside the manifold, but outside the manifold. This Loctite Forma gasket isn't too bad. The GERTV also works fairly well too. Smear it off as smear it around a little bit if you want to get it on the sealing area. That sometimes helps to seal everything too. It doesn't really hurt too much. Put the excess around there. When you put the gasket on, make sure that you rotate it around the stud in such a way as it tends to cover the Allen head bolt area. If you just put them on randomly, you may have a carburetor air leak. Get out the proper side. This is the proper side. We, out of necessity, just ran a little U-tube between the two vacuum ports, just so they will temporarily, we get the right plugs for them, but we don't have them right now. It also helps now to get out the proper screws, nuts actually. You can use either 12 or 13mm across the flat. Again, 13 is a little more common these days, so I think we'll be using 13 on these. You can use either the thin washers, a smaller outside diameter, or the thicker ones. The thick ones are kind of hard to get anymore, or the large outside diameter washers are hard to get. So we'll just use the thin, regular 8mm gaskets. Put the nicest looking nuts towards the front. It also helps to use the one that's in the best shape here. This is the hardest to get off nut, and you like to get the best grip on it possible, so use the nut in the best shape there. Make it look as nice as you can. It's a little tricky getting to some of these, but it's not too bad usually. Tighten them down evenly, of course. That's the trick of the trade, is to make sure everything is being tightened down evenly. And we will tighten this down for you. May as well do it now. Show you how one goes on. Put the other one on, and then we'll adjust the linkage, set the timing, put the fuel line on. Note that I like to have the fuel lines point towards the front of the car. That way you can use your stock fuel line. You have to cut the banjo fittings off, so you might want to pick up another stock fuel line at, say, a swap meet or something. Get the nut, it's hard to get to a nut as tight as possible with your fingers before you use the wrench. Minimize the number of 8 turns at a time that you have to do. Let's see, if you're using the manifold adapter plate, that will space the carburetor out enough to where you won't have any interference problems with that choke block-off plate that we discussed. If you're using just the Weber manifold, then you sometimes have linkage or interference problems with the choke block-off plate hitting the spring plate on the other side. I'll show you that in a second when we get this one snug down. It's pretty good. On the other side of this, when you're going to put the right-hand Weber on, the spring plate is held by 3 bolts, hold the top linkage crossbar. If you put the carburetor on, you'll find this one, get a close-up of that, this one screw that holds the block-off plate can come awfully close to this nut that holds the spring plate. In fact, if, get it over a little bit, if you're using the Weber manifold, which actually rests somewhat lower, the adapter plate raises these things up. If you're using the Weber manifold, this screw will hit that nut and cause great problems. In fact, when you try and tighten the carburetor down, you may bend something, or put undue stress on the spring plate, or both. So be careful when you put these on. Look at everything and make sure you have no gross interference problems. So get out your gasket material. Again, put a little on. That's a little bit too much on there. Move some to the other side. Like I said, this is not the finest applicator I've ever seen, but it'll work. The GE RTV is actually a little bit better. You can control the amount a little easier than you can with this tube. I thought I'd try something new and different with the Loctite, since I do like Loctite. I like their products. But we can spread some of this around and act as a bit of a gasket sealer too. Don't overdo it. Just get enough on that nut so that when you tighten down the carburetor mounting nuts, that you will then have material squeezed out to the outside and not overly. We'll go around afterwards and clean all this good stuff off. Again, arrange the gaskets so that they will seal off over the top of the 6mm Allen head. Carefully arrange that. Put the carburetor down. Get your... Alright, again, use the nicest looking washer. Washers on the front, the other ones on the back. Note how much the studs protrude above the carburetor. If we had tightened, inserted the studs a little more than we had done when I was discussing that you might find that you wouldn't have enough meat on the stud left to grip the 8mm nut. But since you're warned of that in advance, you do have enough, and everything will be cool. Alright, next step after we get the carburetors on, you either do the linkage of the fuel line. I suppose at this point you may as well do the fuel line. And as I was saying, you should get the stock fuel line. That's one I like to use. If you don't want to use your stock fuel line, it's okay. Just get a brass T and make up a fuel line out of rubber hose. I like to use the German rubber hose. I find it fits the Porsche lines the way it's supposed to. Lasts a long time. Looks pretty good. The American rubber hose is a lot bigger. Actually, the wrong inside diameter. A little bit too loose on the Porsche metal lines. And when that happens, you can sometimes get leaks. I would use clamps on everything. I've seen some engines come through with no clamps on the fuel line, and the fuel pump can produce, a good one, can produce about 4, 5, 6 psi, pounds per square inch. And you can blow off fuel lines that don't have clamps on them. You blow off a fuel line that doesn't have a clamp, and you end up